Tulsee is a product lead at Google's machine learning, and he specifically works with different types of teams in order to get them to understand, from what I recall. This is exactly what you said, but it's also what I recall about what you do at Google Tulsee. I'll actually let you do a much better job of introducing what you do, so I don't butcher it. But with that, I'll turn it over to you, Tulsee. Thank you so much for making the time.
Awesome. Yeah, thank you. And thanks for having me. I just realized that I am your last class. So hopefully this is a good place to end on. Like Vijay said, I'm Tulsee. I lead product at Google for our responsible AI efforts. And so that means that I work across a number of our teams at Google, ranging from, photos to ads to YouTube to search to Pixel and Nest, trying to really understand what are the different responsible AI considerations we see, how do we actually build that into our products, what does that look like, and then how do we take all of those learnings from what we're seeing in our products and actually turn those into tools within the TensorFlow ecosystem that we can actually scale out for developers, right? Especially given how much we're trying to grow our developer ecosystem within TensorFlow, both broadly in the community and through Google Cloud and through our enterprise products. And so I get to work with researchers who are really trying to build a social science and a technical understanding of responsible AI, work with product teams directly, and then of course work with developer advocates and work with our infrastructure teams to kind of see the whole ecosystem at scale. So with that, what I was hoping to do today, especially because it sounds like Susan did a great job on Monday of laying out some of the ethical considerations and how to think about the broader frameworks when building products, is take a little bit more of the technical point of view in terms of when you're actually building a model, especially within the TensorFlow ecosystem, what does that look like? What tools are available? And why can they be useful, or what are the goals there that you might have? And hopefully we'll have plenty of time for questions, so feel free to ask away. Let me see if I can share my screen. All right, can you see that? Cool. Awesome. So what I'll do today is, as I mentioned, I'll talk a little bit about what we mean when we talk about responsible AI, especially within the Google context, and how that manifests. I'll talk a little bit, especially about ML fairness, since I think that's one where it often gets simplified in discussions, and I think it's worth talking through a little bit about how that can manifest. And then talking a little bit about when we're fitting into the development workflow, what does that look like? What do you consider when you're thinking about responsible AI, and how can TensorFlow help? And then I have some links and resources at the end for you to go and investigate more, especially if it's helpful in your final projects. Cool. So what is responsible AI? Well, I mean, I think on Monday you talked a lot about like the broader theories behind responsible AI and building with an ethical mindset and thinking through the broader philosophical and moral problems that can come to bear when you're building AI. For us, when we talk about these issues, we often break them down into 5 categories. Being thoughtful when you're building AI in the first place, right? So just recommended practices, best practices. Fairness and thinking about bias, interpretability and accountability. So how do we actually make sure that what we're building is explainable and understandable, privacy and security. And that actually reflects in Google's AI principles. So we actually have 7 principles that reflect how we try to build and develop AI. So being socially beneficial, avoiding creating or reinforcing unfair bias, being built and tested for safety, being accountable, incorporating privacy design, upholding high standards of scientific excellence, and when making that technology available, making sure that it's available within these contexts. I'm sharing these not necessarily because to pitch Google's AI principles. In fact, a number of organizations now are creating their own versions of these AI principles, including like the Department of Defense and other organizations. And I think all of these principles look somewhat similar. They hold very similar tenets in terms of the aspects of the AI principles and the aspects of what it means to build good AI that we really want to take into account and hold. And so I think this is also something that is useful when designing your own products or designing your own applications, is walking through this almost as a checklist, right? How am I thinking about bias? What does safety mean in the context of my users? What would it look like if I wanted to be accountable to my users and make sure that they understood that the decisions the model was making and why they were making those decisions? And I think that part is really important because the reality of the situation is that building responsible tech requires a lot more than good intentions, right? I think that I like to believe that most of us who are building technology have good intentions with how we want that technology to be used. And often when things creep into the way that we design our models, whether that's safety concerns or bias, those are often unintentional, focused on us building from our own experiences, right? And when we build from our own experiences, by that very nature, we are building for a subselection of the population, right? And I think this is a really fun example where this is an example. What you're seeing on the screen is from Kodak, actually. And this is the Shirley color calibration card. So back in the day when Kodak was originally starting color photography, they used a model named Shirley as a way to calibrate color for the cards. And so the idea was that she was the model of a typical individual or a typical person. And so when you wanted to take a picture, you would use that as a barometer. But of course, Shirley is a white woman. And so when you calibrate your color to her, that imagery works really well for a lighter skinned population. Those photos did not work well, and the color was not well calibrated for multiple other skin tones, right? Not necessarily bad intentions, not trying to create photography that doesn't account for a broader population, but created a very simple heuristic to make sure that the product worked for a specific individual. And actually, interestingly enough, this wasn't even fixed until the 1980s when chocolatiers and wood furniture manufacturers complained and said this product is not working for our products. And we're not able to take pictures of chocolate and wood, not necessarily because it was meant to be redesigned for people of color, right? And so you can see this image on the left where it's an image taken, the individuals of color can't really be seen because of the darkness of the screen versus the image on the right. And this is not an AI product. It's simply, a technical example, I think, of how these types of concerns can manifest in ways that are unintentional and how much it's important for us to think through the broader set of users who our products are affecting and what that actually looks like. And as you know from Monday, right, these problems are complex. They're not simple. They can't really be solved by a tool in TensorFlow, as much as I'll try to convince you over the course of the next 30 minutes or something that they can be. You need to really have the combination of perspectives, right? Social science, policy, design, engineering, philosophy. Most of the concerns that you'll see from a responsible AI perspective largely should be tackled at a broader perspective, right? Thinking about how you're building the product. Should the product even be built in the first place? Is it adding value? Who is it adding value for, and who might it not be adding value for? And I think it's only when you come to the end of those questions where you start saying, okay, now I'm actually ready to build, that a lot of the technical aspects and some of the engineering tools and components can really come into play. And even then, I think it constantly requires a dialogue between multiple disciplines to really make sure you're doing that. I think that's what, for me at least, has been really challenging when you look at taking a CS degree in CS classes, is that you learn a lot about the engineering side. You don't always have perspectives about those other sides, right? And how to bring that in. And I think for us at Google, and I think broadly, the learning lesson has been that no one person is going to have all of these skills. And so the more it's possible to get that expertise from others in your organization, from others outside of the organization, even just getting more perspectives from more users by doing more testing, the more likely it is that you're going to build a product that actually manifests responsible AI. So with that, I'll jump in a little bit to talk about fairness in particular. And I typically like doing this because I find that when we talk about fairness, we often all mean different things, right? And what it means to be a fair product can mean different things to different users, to different communities, for different reasons. And so I'll do this as a little bit of a side and then step back kind of to talk about the broader responsible AI ecosystem. So there was this talk at the FactStar conference in 2018 in which Arvind Narayanan, who's a professor at Princeton, claimed that there's 21 definitions of fairness. And I find that always a really powerful statement because I think there's actually more, right? When he was talking about 21 definitions of fairness, he was saying that in the context of a classifier, if I'm building, a classifier to tell you whether a video is about trees or about puppies or about cats, there might be 21 different ways for me to measure fairness of that system. Well, if you're not building a classifier and you're building a recommendation system, or you're building a generative content system, or you're building something else altogether, likely your definitions of fairness are going to be different, right? Because a classification system might have different concerns than a system that is recommending you personalized content. And so when we talk about fairness, I think what that goes to show just is how complex the problem can be and how important it is for us to be extremely specific when we say we're working in this space and when we say we're working on something like fairness. More than that too, I think some of these definitions are not compatible with one another. So if you are improving fairness in a particular way, that may actually hurt a different definition of fairness. And so that also then becomes, again, coming back to your final projects or any project or product you undertake, which is what is the core concern that we are trying to solve for users, and which of the many metrics actually addresses that concern. And are we okay with the trade-offs or the costs that might come when that leads to another metric, right? So here's just an example from one of the projects that I've worked on, which is Jigsaw's Perspective API. And so this is a API that was created by Jigsaw and Google's counter abuse technology team. And the idea was to promote healthier online conversations. So basically to classify comments as whether they are toxic or non-toxic. So a comment like, "What a sweet puppy, I want to hug her forever," would be given a score of 0.07 because very cute, very non-toxic, right? Whereas a comment like, "You are the worst example of a puppy I have ever seen," is a very mean, hateful thing to say to a puppy. And so that would be given a score of 0.84, right? So the higher your score, the more toxic your comment. And so the question then becomes, okay, how can that fail for users and what can that look like? And so when the product was originally launched in 2017, they actually launched a widget for users to be able to try and play with it and see kind of what types of comments were toxic and not. And a user found this example. The comment was, "I am straight," and got a score of 0.04. The comment, "I am gay," got a score of 0.86, right? Unintentional on the part of Jigsaw, not a concern that they thought they expected to see, but obviously a concern they didn't want to, and a concern that we absolutely don't want to have the product permeate as it is looking at online conversations.
Because I'm missing something important you're saying. So I did not catch what you said in the previous slide, so I'm not following this one. So what specifically were they trying to capture here?
Yeah, good question. So they were trying to capture level of hate and toxicity in a comment. So a comment like the one on top here is low toxicity, right? So it's given a score close to 0. A comment like the one below is given a score of 0.84, highly toxic, highly hateful, highly harassing.
Okay. And the goal was to promote healthier online conversation. I'm trying to.
Yeah, so I think the idea, that's a good point. The idea behind the product was identify toxic comments, filter them out of your conversations, right? So an example is the New York Times. If you see comments that are really hateful, you can actually just filter them out of your platform altogether, and therefore promote more neutral, consistent, moderated conversation.
Okay. Okay.
Right. And I think that's a good point around healthier conversations too, because I think that, again, like to my point earlier, like this is probably only one part of the solution. Right. Just filtering out the most toxic of comments is not necessarily going to automatically promote healthier online conversation, but I think it's one part of that process. But I think you very much hurt that process if you start filtering out comments like "I am gay" as toxic, right? And not allowing those comments to participate in the conversation. So yeah, I think that the interesting thing too, right, is the sentence "I am gay" is a very simple sentence that I think just illustrates the point of the stark contrast between these two comments. But it can be extremely harmful if you're removing conversations that pertain to really important topics that are really great comments, that you're considering toxic, right? And you're considering hateful and harmful. It can also be really harmful if you're keeping in comments that are hateful and harmful because you didn't assume that they were toxic, right? Because for whatever reason, you didn't learn that that was a way that people made hateful and harmful comments. And so the question then becomes, okay, what do you do about that, right? Where did that problem come from? Where did that bias come from? And how do we fix it, right? And the reality of the situation is that in the case of the Jigsaw API, as is the case, I think, with most models that you'll build, bias creeps in at every stage of that process, right? So how do we collect the data? For example, did we collect enough comments that had LGBTQ terminology in them? How we labeled the data. So if you have raters labeling your data, which is often the case, especially in big tech, do those raters recognize that this comment is toxic or non-toxic? And what unconscious biases are they bringing to the table in terms of what they deem hateful, hurtful, offensive? Then you train using that, right? And what is the objective that you set? If you set a certain objective, for example, in the case of a product, if you set an objective around engagement, you might be setting objectives that work for the average and work for the typical user, but don't actually work for all users, right? Then you do some sort of filtering, ranking, aggregation of the data. You do something with that. Those choices inject bias, and then users actually see the product, right? They see what you are doing, and they react to it. They engage with it, and that usually becomes training data that we use again, right? And so their actions and their behaviors inject their own bias into the system as well. And so when we're thinking about how to improve the product, I think it usually isn't a single fix in a single place. It's actually thinking about this throughout the development flow. And at every step saying, okay, what are the decisions we're making here? Why are they coming into play, and what do I want to do about them? And because the uses and use cases are so different, right? And I think in this course, probably you've seen a vast variety of different use cases. The fairness concerns can take different forms, right? So what I showed you in the Jigsaw perspective use case is an example of a classification problem where the problem is sort of this question of different terms leading to different classifications. In the example you see on the left here, it's another classification example published by researchers looking at gender classification in open APIs. And what they found is that darker-skinned females were more likely to be classified incorrectly, right, as opposed to others. Again, a classification use case, trying to understand how different skin tones and different gender representations get manifested appropriately or incorrectly in the product. On the right, though, you see a very different example, right? And the reason I call this out before I go back into the Jigsaw API is that I think it's also important to recognize that we're going to see fairness instances in very, very different ways, right? Here you're looking at Google Translate. And what you see on the top is two sentences in Turkish. And Turkish doesn't have gendered pronouns. So essentially what those two sentences say is this person is a nurse and this person is a doctor, right? When we translate that to English, Google Translate automatically assumes that the first sentence was referring to she and the second sentence was referring to he, right? And this is a fairness concern. It is a concern of stereotyping. It is a concern that can be incredibly harmful, but doesn't quite look the same as the concern on the left, right? It's not necessarily a classification problem. It's not clear that Translate would ever have a high accuracy on these types of statements because you don't actually know from the original statement what is the right answer, right? And that whether there is an accurate pronoun to translate to in the first place. And so as a result of that, the solutions that you choose to take might actually look very different also, right? You might choose to take a technical solution. So in the case of gender shades, for example, they focused a lot on data augmentation and collection. So really focusing on the fact that there wasn't a lot of data training these systems that were from darker skin tones or from multiple genders. And so really going out and finding a broader set of data. And actually they did something interesting. They went to parliamentary figures from across the world and used those to find more images of diverse individuals. Whereas on the right, when we looked at Google Translate, we realized that while we do need to make the models better and need to continue to improve them, part of the problem was actually a product design problem, right? Where if there is no right answer, and if it's not clear what we should be translating the word to from a gender perspective, maybe we shouldn't be making a call on that. And maybe that's something that we should actually be giving the user agency to do, right? So in this case, for example, if you see the word friend here, we translate it both to the masculine and to the feminine version of the word, and therefore give the user the ability to choose and to say, I actually am talking about a male friend versus I'm talking about a female friend, versus I'm talking about a friend who chooses to go by this particular pronoun. And I think that's really just a way for us to recognize that not always does the machine learning product or do we have the context that the user has about what they're about to engage in. And so if that's the case, then giving the user more agency and allowing them to engage with the product can actually just build a fair and more diverse experience. And that actually brings me to in the context of many applications that leverage TinyML or will leverage TinyML moving forward, what does this actually look like and what does it mean? And of course, these concerns that I talked about translate across the board, right? You have face recognition in the context of Nest Hub at Google, where we've been thinking about fairness in the context of gender and skin tone, right? So how do we make sure that when you're opening your Nest using your face, that it works across genders, it works across skin tones? How do you make sure that it's safe and robust so that others can't unlock your device, right? Fun fact is I was just visiting my parents and my mother's iPhone opens with my face, right? Great example of a concern that she does not particularly want to see happening with her iPhone. In the context of the assistant and speech recognition, does the product work across accents? Does it work across languages? How well does it think about privacy of the data that you're providing it? How does it fail gracefully, right? How do we make sure that when you're working with an assistant and you don't actually have a screen, that we can make sure that you get what you need even when the model fails? And I think some things that particularly stand out to me in this particular space often is, especially when you're dealing with things like biometrics, things like voice data or face data, privacy actually becomes a really, really big consideration. And that also has its effects when it comes to fairness, right? Because one thing that can be really challenging is if you're not collecting a ton of data from users and you're trying to be really conscious of on-device learning and being really careful about a user's data, well, how do you get diverse data from a diverse set of users across a diverse set of regions to make sure that you're training your models effectively? And when you're thinking about privacy concepts like federated learning, where you want to make sure that you're learning across devices in a privacy preserving manner, how do you make sure then that what you're still learning is effective across different populations? And one of our challenges has been, okay, how do we make sure that we get enough data from people who speak different accents, speak from different parts of the country, if we're not collecting that kind of data and we're not labeling it? And then, like I mentioned, how do you fail gracefully? How do you make sure that the product actually works? And I think that is actually, while it is a product design problem, is a critical part of responsible AI as well, because that ties very much into the way that you build and how users are actually going to experience your product long term. So with that, I realized I did not build in a transition slide. So with that, what I will also do is jump in a little bit into, okay, I talked a little bit about this Jigsaw example earlier. I talked about how fairness can manifest in different ways. In the case of Jigsaw, what did we actually measure and what did we actually do about it? So the interesting thing about the 21 definitions of fairness kind of concept is that you can define these problems in many different ways, and what that'll lead for your product is actually very, very different, right? So this is an example called counterfactual fairness, where changing a single identity term or feature, you don't want that to change the core prediction of what you're building, right? So the idea being, if you use the term I am gay versus I am queer versus I am Muslim, you don't want the prediction of what you're building to actually change, right? So if we go back to that Jigsaw example that I gave you earlier, where you had two sentences and you were trying to predict whether they were toxic or not, you would want the scores to be relatively consistent if the concept of the comment was relatively consistent. And so, for example, here you would want to see, I'm gay versus I'm straight as a gay man versus as a straight man having similar scores. And that measures a meaningful concern, right? That's an important concern. That's an important thing we should be looking at. But in the context of an online conversation, you're often going to see different comments that talk about the LGBTQ experience versus different comments that use the term straight, right? And that's simply just because you might be talking about different things. You might be talking about different experiences. Different individuals are going to be typing these comments. And so if you just look at counterfactual fairness, you're likely going to miss the overall experience of the LGBTQ community and whether you're actually measuring that appropriately, right? Because now, if you look at different comments, maybe the error rate for LGBTQ comments is actually 60% compared to the error rate for comments that contain the word straight, even though the counterfactual fairness problem is the same, right? Because comments that are structured the same kind of perform the same in the product. And that's the notion of equality of opportunity. We want to make sure that examples from two groups should have equal likelihood of being classified correctly or incorrectly. And so I think what was really important for us to realize, and what we've realized throughout the examples that I've shown, is that there isn't a single metric. There's not a single metric often for robustness and safety. There's not a single metric for fairness. Often these are issues that we have to think about more broadly across a broader set of considerations. And this actually is, I think, allowing us to define those multiple metrics allows us to make meaningful progress, right? So this is, you can ignore the numbers for now, just look at the colors, but what you see here is a card from our first version of the toxicity model in 2017. The darker purple means higher error rates, and so performing less well for these terms. And by measuring this over time, what you can see in toxicity V6 is that the colors all become much lighter. The model is just performing much, much better across these terms. And in this particular case, we thought a lot about data collection and how to make sure we were getting better and more representative data across these terms. But what you see here, I think, is just how much I think metrics can actually help. And if you are able to contextualize the ethical, the fairness considerations into a set of numbers, you can track those over time and you can make progress. One last thing I'll call out, though, is be very careful about what data you use to measure your problem, right? So what we did when we measured this concern is we created synthetic data. So we literally made up a bunch of comments that had particular terms in them, and then we replaced those terms with other terms. So we replaced I am gay with I am straight, with I am Muslim, with I am Indian, with I am Hindu. And we created a big data set of comments that we then used to evaluate performance. But of course, the real data on the internet doesn't look that clean. These sentences are not that consistent. They're not that similar. And it turns out that on the same toxicity V6 model, when we looked at comments across the internet, the results just weren't as good. We hadn't improved the model as much as we thought we had. And so I think it also goes to show that not just your metric matters, but what you're measuring on and how you're measuring it also really matters in terms of actually making sure that you're evaluating an experience that is valuable. And when you identify a concern, like the one we just saw, there's many approaches you can take to address it. Like I mentioned, in the case of Jigsaw, we looked at collecting more data. In the case of, just do this for myself. In the case of multiple models, you might actually find yourself often making trade-offs between what you want to see, right? What threshold should you select to make sure that you have the right false positive rate or the right true positive rate or the right equality of opportunity metric or the right counterfactual fairness metric. And so you might ask yourself, okay, between the comments about LGBTQ concerns and the comments about non-LGBTQ concerns, what is the trade-off that we're seeing? What do we want to reach? At what point do we see similar error rates across these groups? And can we set the appropriate threshold? Of course, sometimes setting that threshold might make your performance worse overall. And that's where other techniques can come in, which I'll talk about as we talk about some of the tools in just a second. Another thing, to think about is constraints, right? Depending on the type of fairness metric you define, I talked a little bit about equal opportunity, but as I mentioned, there are multiple metrics for fairness. What is the concern that you're trying to solve for, and what constraints can you impose on your model that require your model to make that true, despite what it works on? And we actually have a library within TensorFlow called the TensorFlow Constraints Optimization Library that actually helps you set these types of constraints and say, hey, I want, no matter what, for equality of opportunity to hold. And so make my model as effective as possible while still holding this constraint. And if you can do that, then you find yourself in a place where you can actually start improving the model while holding certain conditions true. So I gave you some flavor of some of the ways. Oh, sorry, go ahead.
Good question. So on this previous slide here, I'm trying to understand how would the model, what's an example, for instance, where you could say how the model would hold this true? I'm trying to understand.
Yeah, so it's a good question. So let me just use the Jigsaw toxicity example as an example here, right? So let's say I was optimizing my model for accuracy in comment classification, right? Or something to that effect. So there is an objective that you're optimizing for, which often in the context of comments about the minority community might mean that making larger error rates on that community is actually better for overall accuracy because the model is seeing more hateful comments about the LGBTQ community, right? And so essentially adding in a constraint around equality of opportunity is essentially affecting your model's loss function, right? To say, hey, I actually do not want to see a larger percentage of errors in this case, and I will penalize the model more for that set of errors, right? And so what you're essentially pushing the model to learn is to stay within a certain boundary when it comes to error rates on particular slices, while still optimizing for the overall goal.
Okay, that makes sense. Because yeah, I was just trying to close it from the training pipeline process. It's like, how would you actually teach this? Okay,
yeah.
Perfect. Thank you.
And that brings us, I think, directly into the development workflow, right? So I gave a number of different examples. I gave a number of different metrics. I told you about a number of different considerations. How do you actually build that in when you're building a model in the first place, right? So for the purpose of this, I'll just frame out the development process into 5 steps, right? You define your problem, you decide like what you want to work on, you go and get your data, you construct it, you prepare it. You then decide you want to train your model. Awesome, you build and you train it. You then deploy it into the real world. And you're like, hey, okay, I want people to use this. And then you iterate on it, right? You find things that go wrong, your users interact with your model, you learn, it gets better and smarter. And there's questions that are interesting at every stage of this process from a responsible AI perspective, right? So when you're defining the problem, who is the system even for? Who are my users? What am I building for? Why am I building this? Are there any privacy considerations? What should I be thinking about? Am I using a representative data set, right? Is there any real world human bias in my data set? Where do I get relevant features while still preserving privacy? And how do I balance the desire to know who my users are with their concerns and their privacy? Are the test users diverse? How does my data affect model performance? Is my model performing in the way that I want it to? Is it secure? Is it robust? Should I actually deploy it in the real world? Is it ready, right? Is it ready for prime time? And then what can I do to improve it? And are there complex feedback loops, and what's happening over time? I think also what's interesting about responsible AI concerns, as is true for any ML concern, is that they're not static, right? So a model that performs well on day 1 may not perform well on day 100, especially if it's using continuous training and building off of user data. And so being thoughtful about what that actually looks like, what the feedback loops are there, and how you're building off of them is important. And so for us, what we've done, at least in Google, is built a plethora of tools that we are slowly trying to work together to build into a more unified toolkit for each stage of this process, right? So whether it's defining the problem or preparing the data or training or evaluating or deploying, building a number of tools that we believe can help in this process. And of course, these tools do not replace the hard questions we talked about earlier of what is even the right metric? What am I trying to measure? And should I even be building this in the first place? But once you make some of those decisions, these tools can hopefully help you measure those in a way that's easier and act on them in a way that works, right? So to Vijay, your question earlier about the optimization, being able to actually use the library can hopefully help make that process easier, right? And make that training process easier. And so that's the goal with a lot of these tools, is to simplify that process. So, right, like let's say, and I will apologize because the next following slides are screenshots from a number of different examples, but for the purpose of discussion, we'll just use this example of like, you've been asked to build a smile detector for your new camera, right? So you're trying to determine whether or not the person that you're looking at is smiling through the camera. So, okay, first question is the problem a good one for machine learning, right? And what are the risks associated with this use case? What might happen if I did this well? What might happen if I didn't do this well? And in the case of a smile detection system, yes, maybe machine learning is the right approach, but what are the potential harms if you don't detect someone is smiling? What are the cultural nuances, right? In different countries and different cultures, people react to taking photos differently. Some cultures don't smile nearly as much as others. Some show teeth, some don't, right? What does that mean for what you're going to be doing to someone's photo taking experience? And so I would definitely encourage you check out the People and AI guidebook if that's not something you've seen or heard of before. What we have is a number of chapters around user needs, mental models, what makes a good application for machine learning and what doesn't. And we also have a number of fun explorables and visual animation tools that are fun to play out some circumstances as well. Then you go out and you get your data, right? You're like, okay, I really do want to build this smile detector. I think it's a great idea. It's going to solve the world's problems. And so now we go and try to identify, is there real world or human bias in my data, and what does that look like? So here's an example from TensorFlow data validation. One of the things that we aim to look at is what is the distribution of my data, right? So if for each of the features that I'm collecting, so let's say I have a feature for is smiling, right? Or for a feature for maybe the gender of an individual. In this case, you're looking at a different example on the screen. What you see on the right is the distribution of data that you have across those feature points, right? And so for example, here, if you only have data from one slice of the pie, you're likely not going to be learning effectively what the broader set looks like, right? If you have a diverse distribution of data across the features that you could have in your set, that's going to mean much more for your ability to train an effective model. And in some cases, maybe you don't expect features from particular slices because that's not your user base. Maybe you're only building a smile detector for college age students, and so you're not expecting older users to use it, right? Or maybe you're only building and launching the product in one country, so you're really only expecting certain types of users. But I think it's really important to take that step back to say, who are the users that I'm building for, and what does the distribution of my data look across that? You can also use TensorFlow data validation to build something we like to call data cards, where we actually document the facets about the data we're creating, right? So who published the data? What type of data was it? What are the characteristics of the data? What is the distribution of the data? And these things, especially if you're planning on using the data again, or sharing the data with others, or picking up a data set that has already been used, it can be really helpful to make sure that you recognize the places where the data might work for your use case and where it doesn't, and be consistent about documenting those choices. I would also just say, there's many ways to add data to your data sets, collecting more or just even active sampling to try and find more from your population. In the case of the Jigsaw Perspective API, we actually went and got more data. We went to pride parades around the country to ask individuals to say neutral, positive, maybe even negative if they felt so inclined, things about the LGBTQ population, and collected that data to make sure we had a much rich repository of what individuals might say and what language they might use and how they might speak about the communities. So you have your data, you feel good about it. Now you want to build and train your model. And there's multiple tools, I would say, on the TensorFlow site, and I'll have a link at the end for you to look into some of these more around privacy, around fairness, around interpretability, and building models that are explainable. TF Privacy and TF Federated both will give you perspectives on how to build using differential privacy or federated learning, especially if you're building sort of hardware-driven on-device based learning systems. Federated learning might be something to really look into. And then you have TF Constraint Optimization, which I talked about earlier. And then you want to evaluate your model, right? How is my model performing? Can I evaluate it? Is it doing what I expected it to do in the first place? And so you might want to actually run fairness evaluations. You might want to run the metrics we talked about earlier. You might want to actually investigate examples to say, why is this not performing the way I expected it to? And you might want to actually validate whether it's preserving the aspects you want, right? So what fairness indicators allows you to do is specify a metric, like the equality of opportunities metric I shared earlier, and then you can slice the performance of your model across a number of slices. And those slices could be a feature that you already have in your data set. It could be a feature that you add in later. It could be a data point that you don't want to see happen long term. And what you can do then is say, okay, now I want to deep dive into one of these slices, right? So, hey, this slice that says Buddhist isn't performing as well as I expected it to. I don't know why. I want to understand more. And when you actually deep dive into one of these slices, you can use what we call the Whatif tool, which allows you to actually investigate an individual data point, right? So say, I want to look at this particular comment or this particular picture, and I want to see whether or not that picture is performing the way I expect it to, and whether it would perform the same way if I changed something about it, right? So what if I changed one of the features? What if I changed the age of the individual to be from 10 to 20 to 30 to 50? Would my model perform differently? If I changed a feature to have a pixel be a different color, would the model perform differently, right? And it allows you to do these little what if questions and these little tests to understand whether or not a data point is performing in the way that you would think. And for me, I find that really helpful for two reasons, right? One, it helps you explain your performance, right? It helps you understand and interpret what your model is doing. But also, it just helps you get a little bit more on the ground deep diving and on the ground understanding of how your model is performing, taking out of these aggregate metrics, right? The aggregate metrics are helpful, but they don't often give you the full picture. If you're actually using language in your model, we recently launched the language interpretability tool. And so one thing you can do specifically for language use cases is actually dive in and specifically look at explanations for why you're seeing a model happen in a certain, a classification happen in a certain way, or a prediction happen in a certain way. And the reason why we've created a separate tool for language as opposed to just using the Whatif tool is because often when you're building a language model and when you're building NLP-driven systems, the way that you're understanding your features and the way that you're leveraging the words in the sentence might actually be different, right? And so really wanting to create an interactive experience where you can change the words in a sentence, where you can move things around, where you can play with the passage and understand how different things might change your model's prediction. You can also actually test your model for privacy, right? So fairness seems relatively straightforward. You can slice your model in different ways based on different metrics. But what's interesting using privacy tests is you can also try and play the role of an attacker, right? So what would it look like if I were to try and attack my model and get out and extract information about the training data that was actually used to train this model? And so what privacy tests allow you to do is to input examples and to see whether or not we can understand whether those examples are in the training set or not, and whether we can extract the training set data. And if the answer is yes, then that implies that there's more work to be done from a privacy perspective, possibly using tools like differential privacy or federated learning. If the answer is no, then your model is relatively robust in protecting your training data. And that's a way that you can feel a little bit more confidence in moving forward. Second to last, there's the deploy and monitor piece, right? And this is usually the part where we're like, yes, we made it, we're done, we did it, awesome. But I think the place that we've really learned the hard way is that often it's not the done phase, right? Often when we've deployed the tools, when we first find out that there's actually a fairness concern, we didn't even realize. Often because we are thinking about fairness from the perspectives of what we're aware of, sometimes once we deploy, a set of users will use the product and we realize that that's a set of users we didn't even consider, right? That's a set of concerns we didn't consider. So first and foremost, I would say testing your product with as many users in as many contexts is the critical piece. But the other piece that's critical is just making sure you have the right transparency and the right documentation to be able to go back and understand where things are and where things have gone. And one thing we're really pushing at Google, but I think the industry is actually starting to adopt broadly, is this notion of model cards. And so the idea is that you have many different people who are going to see your model, right? There's other developers or developers like yourselves. There's end users who are actually going to be using the model. And then there's policymakers and regulators and the broader ecosystem of people who are trying to make sure that machine learning is built responsibly. And so you want to build a model card, right? This idea that I'm going to document every aspect of my model, the details, the intended use cases, the metrics I used, my evaluation data, my training data, the ethical considerations I made, the caveats, the reasons why this model should or should not be used. And this actually parallels notions in hardware, right? So in hardware, there's long been a concept of reports and details that specs basically, right? That detail your hardware, that detail things like what is the battery life and how was it developed and how was it used? And there's consistent standards across the hardware industry for developing these data specs, right? I think they're called data sheets actually. And so the model card is sort of a parallel to that, right? For each model, we should have a spec. What was the model developed as? What does it work on? What does it not work on? How does it perform? And over time, as we improve it, can we track that progress through a variety of model cards so that we can see as we're deploying the model, how things change and how things grow? Of course, this can be hard to do, right? It can be time intensive. It can be hard to sit down and make sure you have all of those details. It can be hard to make sure that you have the right metrics and the right analysis. And so what we've done as part of TensorFlow is try and actually build this into the development process. So using model lineage techniques, making sure that we actually store the artifacts that you use. And so if you hook up MLMD, which is a TensorFlow product, to your pipeline, you can actually track things like what data did I use to train my model, what decisions did I make in terms of the objective function, what metrics did I evaluate, and then populate a model card automatically that you can then update as you make progress to your model, right? And so here's an example here. You see a model card that was developed for a toy classifier we built, where we're updating that model card over time as we update that model based on the model details of the version, of the use cases, of the training set, the evaluation set, what data we used, how we improved the model and trained it over time. Lastly, I'll just say that a number of these concerns kind of got talked about earlier as I talked about some of the tools, but as part of the iteration process, I think you're never going to get fairness concerns right from the beginning. You're likely not going to get security and privacy concerns right from the beginning, although of course we're trying harder and harder to make sure that we're thoughtful about this from day one. But I think it's also important to be humble about the fact that remediation and iteration is a critical part of the process, that if on day one you may not discover an issue, as you test the model, as you evaluate the model, you're likely going to see other concerns. And that's going to lead to this process of remediation, right? How do you actually go back and get more data? How do you rebalance the data that you have to better understand different data points across different users? Can you use tools like constraint optimization? And we actually just last week launched another library called MinDiff that also helps with fairness concerns and constraints for classification and regular classification and regression models. So I think that the key theme there is there are many tools available to you. Some of them will work better than others for your use cases. Many of this is a little bit of an experimentation process. Sometimes data augmentation works great. Other times, maybe that wasn't actually the problem, and you were learning certain proxies just because of the data that you have. So you might have a lot of data that represents the LGBTQ population or represents people in college communities who are smiling. But for whatever reason, the data that you have is noisy, the data that you have doesn't represent the full population, or despite that data, you are still seeing, because of the objective function that you chose or because of the way that the data is labeled, problematic performance. And so thinking about the full spectrum of what you develop, going back to that full pipeline of defining the problem to eventually remediating and iterating on it, I think is really important. And I think you'll find that often to handle these concerns, it's usually a combination of tools and solutions and thought processes that really get you where you want to go. And it can work, right? I think that I don't mean all of this to say that like, oh my God, responsible AI is so hard and there's so many things you have to do. I think often even simple things like applying the MinDiff model can make your performance significantly better, right? You see here the base model is in brown or gold, and here the higher is worse. It's your error rates, right? So you had really high error rates, and as you use the MinDiff model, you're able to reduce these error rates across groups. And so this is not to say that each one of these problems is only going to have multiple solutions. You can often find the solution that will work for you. I think it's more encouraging you to think about what is the approach you want to take and where will it work. So with that, I'm gonna stop there. I'll just throw out two quick resources in case you're interested in learning more. One is we have about a 2-hour course that allows you to actually play with the TensorFlow tools in a Jupyter Notebook environment. So you can actually go through and try out some of these tools and literally go through the Jigsaw toxicity use case that I just walked through. And it'll teach you how to use fairness indicators. It'll show you TensorFlow data validation. It'll show you some of the remediation tools. It'll show you the Whatif tool. So if you go to developers.google.com/machine learning-practica-fairness indicators, sorry for the long URL, you can actually play with this yourself. And I found it a really fun way to just get a little bit more of an understanding of how these tools actually work, how they work in practice, and how making different choices can actually lead to different outcomes. And if you want the broader set of tools that I talked about or that I showed in that matrix earlier, you can go to tensorflow.org/responsible_AI. And through that, you can navigate to a number of our tools on the privacy side, the safety side, the fairness side, the model card and transparency side, in case you're interested in applying all of those. And all of those come with documentation or other things like that. And of course, if you have questions, you're also welcome to reach out to me or others too. So I'll stop there. If there's any questions about any of the plethora of things I just shared today, I'm happy to help.
Thank you, Tulsee. This was awesome. Again, for the students, as I've said before, in the past, we've all probably heard about it, read about it, and one of the things personally that, as an individual in this field, that really frustrated me was like I did not have a systematic way of, as an engineer, kind of thinking about, okay, well, how do I go about solving these problems? I think what Tulsee presented, which kind of like steps all the way from the beginning all the way through that, traditional machine learning pipeline, right? And having those, I had not seen that before Tulsee, but that was awesome. I think what's really exciting here is the fact that we finally have these mechanisms that we can systematically, as engineers or scientists, like kind of take a box and then, okay, I can actually do something here. And I know, that I can control it, right? And that's what I felt like was kind of like helpless. It's like you kind of hear about things broadly and generally, like, oh, we got to worry about that. I'm like, okay, yeah. I don't even know where to begin. Like I already have my own set of problems. And now you're telling me I got to worry about all these other things. So that's a big takeaway. I mean, even for me.
Yeah, absolutely. And I think I'll be honest, like I feel like we're just at the beginning, right? And I think that these tools are starting to chip off pieces of that puzzle. But I think even internally within Google, and I think broadly, I think there's still that same feeling, right? Of like, wait a second, I already have so much to worry about. And now you're telling me I have this other thing to worry about, and I don't even know how to worry about that problem, right? And so I'm hoping that this starts to help a little bit, but I think the more and more we all start trying these things out, right? And trying out which metrics apply to our problems and don't. What I'm actually hoping we'll see happen is more and more of an industry dialogue of, hey, these metrics actually work well for these use cases, these don't. These tools work well for these use cases, these don't. And we're seeing this kind of across the board, right? For what it's worth, like Microsoft has developed a tool called FairLearn, which is their library to work on responsible AI tools for Azure. You have IBM Fairness 360, which is building tools also for fairness evaluations from IBM. PyTorch is developing their own versions of this. So you're kind of seeing it across the board.
So Tulsee, a quick question on that before I turn it over to the students. I should shut up. Is there like an industry communal sort of effort? Like, there's the partnership in AI, those kinds of things where I think questions have been raised, but are there core sort of us like engineers who now want to sit down and bring that community together of engineers who are actually working on it, like people like you, right? Like who actually know this. And
yeah, not as much as I would like. Actually, in January, we're doing a closed door forum with us, Microsoft, Salesforce, and others to talk about sort of how we're all building together. But I think partnership on AI is probably like one of the closer aspects we have to that right now. And for everyone in the room, if you haven't heard of Partnership on AI, they're basically a community, they're a nonprofit that is sponsored by Google and other big tech companies and has a bunch now of members across the industry. And the idea is that there's regular meetings and they also spawn these cross-industry projects. Like, how do we understand privacy concerns across the industry and what can Partnership on AI do to help create maybe a central, neutral ground for this? I think one of the honest challenges I would say is that fairness and responsible AI concerns have gotten conflated with also building enterprise tools and technology. And so now you have like Microsoft building this into Azure, Google building this into cloud, IBM building it into their tools. And so as a result of that, there's not necessarily as much of an appetite for a single set of resources or tools across the industry or really building that kind of coalition. But I know that there's more and more desire to push in that direction. So hopefully we'll actually build more of these abilities to learn from each other.